We're here today to talk about sandy soils. I'm Richard Bell, Professor of Land Management at Murdoch University and the leader of the Sandy Soils project of the Soil CRC. There's about 16 million hectares of sands across southern Australia, which was estimated from our recent study done with Federation University for the Soil CRC, and over 10 million of that is in Western Australia. The problem with sands is that they have very little reactive surface area to hold on to water and nutrients because they lack clay and they generally have limited organic matter. And there's lots of things that you can do to try and improve productivity of sands, but going back to basics, if you can add extra clay or organic matter or both to increase reactive surface, then you have the potential for a more or less permanent improvement in the productivity of those sands. So that really underpins what we're trying to do in this Soil CRC project with sandy soils, to look at different types of amendments that can be added to sands that would improve their ability to hold water and to hold nutrients. And we're doing a range of pot and field experiments, both in Western Australia and in South Australia. And we're very pleased to be working with the West Midlands Group on a field experiment that we've set up this year.
Welcome to our soil organic amendments trial that we're hosting here this year at the West Midlands Group as part of one of the Soil CRC projects that is looking at organic amendments to improve soil fertility. And this is a project that we have been working on this year, or for the last 3 years, with Murdoch University as one of the Soil CRC projects. One of the key issues that we have here in our region is soil water repellency, and that's one of the key things that this trial is really looking at, is some of the options that farmers have to reduce soil water repellency. So the key way of testing this is just to put a couple little drops on the soil surface and see how long it takes to soak into the soil. So that area there is not too bad. If it soaks in less than 10 seconds, it's not too bad for water repellency. Something like this here is not going anywhere. It's just sitting on the surface and not going in. And what we can do is we can actually push that around. It's more interested in my finger than it is into going into the soil. Even when it rains, the water doesn't want to go into the soil. And so farmers in our region have been looking at a range of methods that they can use to manage that and to increase the infiltration of rainfall during the growing season into the soil. And some of the common practices they use are inversion tillage, such as moldboard ploughing, where we actually tip the soil, the top 30 centimetres of the soil over, and expose the subsoil, which is not repellent. We bury the water repellent topsoil and that solves the problem. Another way is rotary spading, where we mix the soil down to up to 30 centimetres deep as well, and we dilute the water repellent soil in the top 30 centimetres, so that also reduces the issue. Here is Simon Yeap from Murdoch University, who's going to talk us through a little bit more about the details of this trial site.
So in this field trial at Badgingarra, we're looking at novel soil amendments on wheat productivity under different tillage systems. So we've got 6 amendment treatments, including an untreated control without any amendment. We have zeolite, which is a microporous aluminosilicate mineral that can hold a lot of water. Ironman gypsum, which is a brown loamy soil material with high iron and manganese, and it's a byproduct of the mineral sands mining process at Aluka Resources. And we're also excavated some subsoil clay, and this is one of the more common approaches to amending sandy soils in broadacre systems. And we've also partnered with Seawise, a compost producer here in WA, and using their compost and compost clay products. How these amendments are incorporated is also just as important as what you put in. And so we've got 4 incorporation treatments, including a moldboard plough treatment, rotary spader, and an offset disc plough. And we're comparing that with the control, which is no tillage. To assess the treatment effects, we're measuring responses in plant establishment, total shoot biomass, total nutrient uptake, grain yield, and grain quality. We've also installed soil sensors at different depths at the 0 to 40 centimetres to measure soil water and electrical conductivity. Soil samples were also collected at depth during the anthesis stage in the crop to assess soil nutrient availability and also other parameters such as pH and organic carbon. And so by measuring these soil and plant parameters, we hope to identify the soil amendments that are effective at increasing both water and nutrient retention, as well as improving crop productivity on sandy soils.
A bit about the season this year. This year we've had 669 mils of rainfall for the year to date. That's to the end of October. That's compared to 537 annual rainfall term average for this site. That means that we're well and truly above. We're in like a decile 7, decile 8 type of year. And one of the other issues that we have, that amount of rainfall on these very sandy, low clay content soils, is the leaching of nutrients, which can compound, the issues with plant establishment. And so what we end up with is very light, low yielding crops typically. And so part of this trial will be assessing some of those organic, the amendments we've put on here, to see if they change the availability of nutrients to the crop during the growing season. Okay, so looking at some of our treatments, our soil incorporation treatments here now, we have 3 main ones that we're looking at in this trial: moldboard ploughing and rotary spading, and we're comparing that to the control, which is no incorporation. This is the rotary spading, where the soil has been mixed up like a rotary hoe, about 20 to 30 centimetres deep, and it's mixed all of the topsoil up with the subsoil. The subsoil has a higher clay content, so that kind of increases the clay level at the soil surface and increases the surface area of the soil, and it also buries that water, or mixes up the water repellent soil. So if we look at this one now, water goes straight in and it disappears. The third treatment is the moldboard ploughing, and so the moldboard ploughing actually tips the soil at the top 30 centimetres of soil completely over. So what we see here now is the subsoil from 30 centimetres down, now is a soil surface, and what it's done is buried the water repellent soil down below. Here is that there's a lot higher clay content, a significantly higher clay content, and the water goes straight into the soil now. So we hope that this video today has given you a little bit of an insight into what we've been working on this year in the West Midlands region, in partnership with Murdoch University and supported by the Soil CRC. This site, looking at different incorporation methods and different soil amendments, has now been harvested, as you can see, and we look forward to getting the results in the near future and being able to tell everyone about what we've found. This trial site has been a partnership between Murdoch University, who bring the research capacity to this trial, with the West Midlands Group, who have the practical connections and the links with farmers and active trials right throughout the region. It's also been supported by the Soil CRC, who link us nationally with a lot of other projects that are working on improving soil health. So thank you for watching, and we look forward to bringing you the trial results in the near future. Goodbye.